Winters are around the corner and there is a perceptible chill in the air. But of course, in today's lecture, I'll not ask you to brace yourself for harsh winters and take out or purchase new blankets and quilts. Rather, we'll discuss why these winters are touted or perceived to be harsh. Why we are discussing time and again in the news, you might have read about this term La Nina. What exactly is it? Now, you might think that I would teach this topic with a geographical aspect. It's a scientific concept, but it has been in my mind since a long time to curate and prepare this topic in such a way to make it as simple as possible because that is only what makes it interesting. Okay, temperatures are going down, cold wave, people are getting sick, there's a lot of pollution. So today's agenda will cover a lot of aspects. We are going to discuss not only why the winters might be harsh this year in India, what is La Nina, how it will act in making winters harsh, and how it will exacerbate the conditions associated with pollution, which is a perennial headache, Achilles heel for a city like Delhi who is already grappling with a grim situation of pollution and unhealthy atmosphere. Fine. Mhm. So just bear with me. I'll make it as simple as possible. So the agenda for today is first we are going to discuss what is La Nina, what is the concept, the mechanism behind La Nina, how it functions, the how the global weather patterns are affected. Then we'll approach India. We'll discuss about the impact. This is India weather, the impact of harsh winters, impact on not only people but agriculture. We'll talk about pollution, effect, and additional bonus content. We'll talk about the concept of cold wave. So it is very interesting concept. Fine. So this is our agenda for today. We'll go in a structured and well versed manner. So first of all, definition kya hai? Obviously, we're talking about a scientific subject, but if you read this definitions, what I'm going to write on the board, it will become very easy for you to refer to that because it is very important. In geography, there is no vague term or vague manner in which to define terms. Okay. So first of all, we're going to define what is El Nino. Okay. So El Nino, it is the abnormal warming of the tropical waters of Central and Eastern Pacific Pacific Ocean. Okay, so the important points: tropical waters, central and eastern. So, although I'll show you the globe as well as the outline map, but just imagine we are talking about central and eastern Pacific. So, Pacific is bound by Asia and Australia on the west, and North America and South America on the east. Okay, so here you can see the globe. So here we have this is the Pacific Ocean. So Australia and Asia on the western part of Pacific Ocean. So we are talking about the abnormal warming of the central and eastern part. So this is El Nino. Okay, El Nino in Spanish. is a Spanish word which means little boy or Christ child, because El Nino conditions usually set up around 25th December, that is around Christmas. So, little boy. Now you can obviously perceive what La Nina will be. La Nina will be the contrasting feature of El Nino. So, La Nina refers in Spanish, it is little girl. So, it is the abnormal cooling of, again, tropical, central tropical waters of Central and Eastern Pacific. Okay. I have no bias towards the pink color being used for the girls, so don't lambast me for it. Anyways, now another. So this is clear. I'll explain the mechanism. Don't worry. Now, some more important. So now, when we talk about the various phases in this cycle, so together this La Nina and El Nino, they form a part of the umbrella phenomenon known as the Enzo cycle, which stands for El Nino Southern Oscillation. Just remember this term, because if you're reading the news, this term will keep on coming. So it happens like first we have a warm phase, then it becomes neutral or normal phase, then we have La Nina phase. Okay, so this again, this Enzo, this La Nina and El Nino, this abnormal conditions, they normally occur at an interval of 2 to 7 years. They are quasi periodic. There is no fixed period. Moreover, these conditions, for example, right now, the NOAA and other scientists, NOAA stands for the National Oceanic and Atmospheric Administration, which monitors the climatic factors, the climatic phenomena. So it has predicted the advent or the arrival of La Nina conditions between September and December, a weak La Nina condition. But that is again a probable chance. They have given a 50 to 60% chance. So it is possible that it arrives and fully settles down. It might not be the case. So normally when a condition of the Enzo, like El Nino or La Nina, it settles, it arrives, it usually persists for few months, but it can extend to years as well. For example, between 2020 to 2023, we had experienced what is known as the triple dip La Nina. Triple dip means the La Nina conditions persisted for 3 consecutive years, which is a unique phenomena, unique occurrence in itself. The last such took place way back in 1973. Fine. So this basic is clear, I think. Okay. What about the other concepts? Just a few more definitions. We have to study about trade winds. Okay. So these trade winds, we are going to focus upon two main types of winds. One are the trade winds or the surface winds. There are two types, major types of winds prevailing over the earth. One are the winds which are close to the surface of the earth, and the other type of winds known as jet streams, they are the winds they blow at an altitude or a certain elevation near the troposphere. Okay, at an elevation of around 9 kilometers, 9 to 10 kilometers above the surface of the earth. So this concept should be clear. So trade winds, so they are the surface winds which blow close to the surface of the earth in a fixed direction throughout the year, prevailing winds. Okay. Then we have jet streams. And the reason they are called trade winds is that they used to help the traders or the merchants to navigate the oceans. I'll show you the map when outline maps. Jet streams. These are swift, narrow, swift, narrow, meandering bands of winds blowing or circumventing the globe in the upper atmosphere or the upper troposphere. Okay. So swift, narrow, meandering winds. So these are the two. Then one or two more definitions. Cyclones. So recently a tropical cyclone has made landfall in India. It is causing devastation in West Bengal and Odisha. The name is Dana. Okay. So cyclones, these are rapidly rotating storm systems characterized by a low pressure system at the center and steep barometric gradient. Okay. So this is the actual definition. I don't want to cut short or miss out on the important terms, but the basic thing what you have to note is that there are majorly two types of pressure. One is the low pressure. So in low pressure, it indicates instability. Whenever there is low pressure, the winds the winds will rise, the winds will converge, they will rise due to instability. The water vapor will condense and it will precipitate in the form of rainfall. Okay. So this is the basic criteria behind the formation of either normal rainfall, convectional rainfall, which we observe in cities like Delhi, or the cyclone formation of cyclones, which normally occurs in the water bodies. Just remember this. Next is, if we talk about next, is the anticyclones. These are important concepts which will help us completely understand La Nina and its effect on winter. So anticyclones, again, they are rotating storm systems, but this time with a high pressure system at the center. So what will happen in case of high pressure? So there is a high pressure system. So the winds will descend and diverge. Okay, so it indicates a system of stability. There is no possibility of evaporation, very less possibility of evaporation, formation of clouds and precipitation. For example, if we consider winter conditions, cold, the air is heavy, it leads to the formation of high pressure. Just remember that if the air is warm, it does not necessarily mean that it will lead to low pressure, and if the air is cold, then it is not always that it will lead to a high pressure conditions. We are just talking in general terms. High pressure and low pressure are relative terms. Okay, so just remember this. And last definition, which we which is very important from the point of view of India, not only just the weather, but also its influence over agriculture. So these western disturbances are extra These are extra tropical storms originating in Mediterranean Sea, and they are carried towards the Indian subcontinent as far as Bangladesh by the subtropical westerly jet stream. Okay. Now it is a long term, but the basic, the simplest way to study a geographical term is to break it down. We have already studied jet stream, narrow meandering, swift bands of wind in the upper troposphere. Westerly means they are blowing from the west, not towards the west. They're blowing from west to east. Subtropical, if you remember your school days, 5th, 6th class, we have various zones. Tropical zone, basically between the tropics. Tropical zone, I'll show you the. So, this is what you need to focus on. So, here you can see I'll mark the important latitudes. Latitudes, what are latitudes? They are what? Imaginary lines circumventing the globe. No. They are, it signifies, latitude signifies the angular distance of a particular place on the surface of the earth with respect to the center. Okay, just remember this. So this is the equator, 0 degrees. This is the Tropic of Cancer or the Kark Rekha. This is the Tropic of Capricorn or the Makar Rekha. This is the Arctic Circle. These are the important latitudes which will help us understand La Nina and the phenomena. Now, first we are going to discuss what we had discussed in the definitions of El Nino and La Nina. So, for that, we have already discussed the trade winds, the surface winds, which blow in a definite direction and near the surface of the earth. So, trade winds, they blow in an area in the tropics between, if we try to be exact, they blow in an area between 30 degrees north and south. The directions will be different in each hemisphere. Okay. So in the north, they blow in this direction, right? And in the south, they blow in this direction. I'm not going to discuss this, why it is so. It will make things extended and complicated. Okay, so trade winds are blowing. Now, during La Nina period, La Nina period, what happens? These trade winds become stronger than usual. Normally, what will happen is if we imagine, if I make a cross section area of the ocean, fine. So let me draw, this is Australia, and this, let us assume, is South America. So, irrespective of latitude, this is the Pacific Ocean. And normally, trade winds are blowing in this direction from east to west in the southern hemisphere. Now, what will they do? They will, because the surface waters will be hotter as compared to the water which is situated at the depths. So, normally they carry the hot water towards the western part. Okay. What happens during La Nina is that these trade winds become more powerful or more stronger than usual. So they move, pile up the warm water they pile up the warm water with high intensity near this area. What will happen is a void will be created because the warm water, the surface water, is being accumulated at this particular direction. The cold water from below, it will be pulled up. So this cooling, so here this part will be warmer and this part will be cooler. Okay, so the trade winds become stronger. They have piled up the water here, the warm water, and this leads to the warming. These are the tropical waters, trade winds in the tropical zone, and the warming of the central and the eastern Pacific Ocean. Fine. So this is the basic phenomena. Now the important thing is that La Nina not just influences a particular winter, it has global implications. Okay, it influences the weather, global patterns of weather. So when we were discussing our agenda, we have discussed the basics of La Nina, trade winds. So now that information will come in handy. So here, just pay attention. So now we were talking about jet streams. There are two major types of jet streams. One is the subtropical westerly jet stream, which blows, this is 23.5 degree north. So the westerly jet stream, it blows in an area roughly 30 to 35 degrees north and south. But we are mainly going to discuss the northern hemisphere for the sake of convenience. Next is the polar jet stream, which circumnavigates the globe between 60 to 65 degrees north. And we had discussed they are fast, swift, narrow bands of meandering winds. They don't blow straight. Okay, so wheel factors are not important right now. So now what happens is sometimes under normal conditions, these polar jet streams and the subtropical jet stream, westerly jet stream, they are doing their job as it is. Okay, sometimes what happens is because in winters, the contrast on the land. Two things you have to remember here. A major cause of formation of jet streams is the temperature contrast, difference in temperature. So normally this area is cold area, this is warm area. Okay, so this polar jet stream is formed. So normally the position of the jet stream is like this over land. It assumes a southward bend. And this normally you can see this subtropical jet stream, it brings in storms and wet conditions, it picks up moisture, it causes rainfall here. Then in during winters we have discussed western disturbances. What were they? The extratropical storms originating in the Mediterranean region. So these storms, the cyclones, low pressure areas, they are created, the warm waters are situated in Mediterranean Sea and Caspian Sea. So when those storms are created, these subtropical westerly jet streams, they carry those storms consisting of moisture clouds towards the Indian subcontinent, and that is how the areas, the northwestern areas of our country like Punjab and Haryana, they receive rainfall, which is very important from the perspective of rabi crops. Like most important is wheat. So if this rainfall, if these subtropical westerly jet streams, their frequency, their intensity, their movement are affected due to one reason or the other, particularly in this case we are talking about La Nina, so it will affect the rainfall as well. So that is why in the last we will also talk about the impact on agriculture. Okay, now, what we discussed in the La Nina phase, the trade winds have become powerful. The warm water has accumulated in this region. This leads to the spread of the cold water, cooling of the rest of the ocean. So it leads to a global cooling, because it does not mean that if the ocean surface or ocean is cooling at one part, it will not affect the other parts. The Pacific Ocean, the cooling is profound here, but it has global implications, not only on the oceanic temperatures, but also because the mixing of heat continuously takes place between air and the water. So air atmospheric patterns are also affected. So what happens is, in layman terms, so the subtropical westerly jet stream is minding its own business. It is going around merrily. Okay. Now this is already here. Cold water is there. This cold water, what it does cool is it sorts of pushes it upwards. It is denser in nature. It says, okay, in layman terms, okay, boss, move aside, give me space. I have to spread. Okay, I am more powerful. I am not as weak as the warm waters. Warm waters are lighter. Just so what happens is, this takes a northward turn. This subtropical jet stream. And sometimes what happens is that the polar jet stream, it becomes a variable jet stream and intermingles or intertwines with the movement of the subtropical jet stream. Just don't think too much about it. So in La Nina conditions, not only are the subtropical jet streams, they go like this, but the subpolar jet streams, they occupy this kind of structure. The meandering becomes more because the meandering becomes more because of high pressure being generated here. So meandering becomes more. Okay. So now what will happen? The subtropical westerly jet streams will discuss the climatic patterns, also the weather patterns, global pattern. So what will happen? It is now predicted. Now the winter conditions, it will become activated fully by January, by December, January. So this kind of structure will be there. So normally what happens? It is predicted due to the onset of the La Nina conditions. You can see that the storm track. You will come across this term also often in the newspaper, because obviously earlier these jet streams were at a comparatively relatively lower latitude. They were bringing moisture rainfall to these lower areas. Now due to La Nina conditions, they have shifted upwards. So this Mexico, southern USA, this will become warm and dry. It will become drought prone in the summers. It will receive less rainfall. Fine. On the other hand, if we consider the storm track has changed, these areas, this northern USA, Canada, and this region here, the northeastern part of USA, Ohio Valley, and others, the Great Lakes, these will become wetter. Okay. And of course, the cold weather will persist. So these are some of the changes which are brought about by La Nina. Because whenever you read the news, why I am not only discussing about India and I'm discussing from a global perspective, is because it remains in the news. And once you get the basic gist of what is going to happen, then you can relate with the various concepts. Apart from that, it is also predicted. Will not go into reasons as to why each and every one reason I have explained here. Then other, due to La Nina, it is predicted that these northern parts of South America will be wetter than usual, like Colombia, countries like Colombia, Venezuela. At the same time, due to La Nina conditions, this eastern and southeastern part of South America, this will be prone to dry weather, droughts. This will be prone to less rainfall. Similarly, like we have seen La Nina, you might have also that we have received normal or significant amount of rainfall this season, despite the late onset of La Nina. Predictions were wrong this time, but we have received sufficient rainfall. So when the rainfall, the monsoon systems in the southeastern region, they become stronger. So as a consequence, it leads to drought like situations in the eastern part of Africa, such as Ethiopia, Somalia. So they will suffer from calamities or catastrophes such as famine, drought, hunger, starvation. And at the same time, other areas will get activated, like northern Africa is bound to receive more rainfall. So this is how. And here also, since warm water is piling, again, just an interesting concept. So, what will happen when warm water piles at a place? It will lead to low pressure, warm, moist air. It will rise, and the water vapor will condense, it will precipitate, and it will cause additional rainfall. So this will be area, eastern part of Australia, eastern part of Asia, Indonesia. These will be prone to greater amount of rainfall, and as a result, greater calamities like floods. So this is how the mechanism of this works. Okay. So this is about the global weather. Now we turn our attention to our nation, that is India. So in this, we'll again consider the two important jet streams. So first of all, you can see that this is the subtropical jet stream. It is blowing just outside the tropics. The tropical region again is between 23.5 degree north and 23.5 degree south. So this subtropical westerly jet stream, what it does is, in winters, it brings moisture from the Mediterranean side and it gives rainfall to regions which are beneficial for rabi crops. Now, during La Nina, what we had discussed, that they have been shifted towards the northern side. So what happens is, due to their shift towards the northern side, and moreover due to they being packed between, because here also cold water was there, here also cold water is there, so they are trapped between two areas of high pressure. Okay, so this high pressure, it makes the subtropical westerly jet stream more concentrated, more focused, and stronger. Okay, and it is the cool phase of the Enzo cycle. So it brings severe cold winds. It does not, in layman terms, it does not have time to pick up warm, moist air, water vapor from this Mediterranean Sea to cause rainfall. So now, if we take down some notes, the reasons for harsh winters, harsh winters in India. So one is the strong and concentrated subtropical westerly jet stream. I'm using the letters too. Okay. Then what else? The strong subtropical jet stream, what it will do is, it will bring the cold winds. See here, if we consider these countries like Iran, Afghanistan, so these are cold deserts, Hindu Kush mountains. So they bring the cold, dry air to India. So this is another reason. The cold winds brought by STWJ from Iran, Afghanistan. Okay. Third is, sometimes what happens is that it is obstructed by high pressure belts. high pressure regions. For example, if the subtropical jet stream is flowing like this, it encounters high pressure belts which obstructs its path and it has to migrate southwards. So southwards when it does, so when it migrates southwards, so it encounters the plains. So cold wave like conditions, colder than normal conditions, they occur in the plains areas of Punjab, Haryana, Uttar Pradesh. So these along with the hills, these also, and obviously this high pressure, not only these winds are being channeled towards the plains and the hills, but this high pressure, this gives the opportunity to the cold air, cold air from the Russian Siberian region to penetrate deeper into the Indian subcontinent. So the cold, so the third reason will be the cold air masses. Normally this is a geographical term. Cold air masses from Siberia. Okay. Then another reason is we had talked in one of our lectures in the Antarctic greening lectures about polar vortex. So polar vortex in plain terms, if I again define it, so polar vortex is again a cyclonic system, that is a low pressure system which is generally restricted to the upper troposphere or the lower stratosphere of the poles. Sometimes what happens is that due to there we have this. We had discussed about the polar jet stream, and here this cold air around the poles is also blowing. So sometimes what happens is kinks are developed. Kinks, it kinks or breakages in the chains are developed, gaps which allow the cold polar air from the polar vortex to penetrate into the lower latitudes. So that is one reason. Just don't go too much into that. And finally, a very interesting, the lack of western disturbances. Now, how are they leading to the chilly conditions? Okay. Thing is, there is very less moisture being carried by the western disturbances. So there is lack of western disturbances. So the weather will become extreme. Okay. So it will, the cold, we will not get relief from the excessive cold conditions. Okay. So this is another reason. So these are important reasons. The rainfall, what it does is, like in summer, it moderates the temperature. In winters also, it helps in moderating the temperature. Fine. Normally, what was happening in the lack of western disturbances, that during the, so during the daytime when it is cold, so the western disturbances they provide relief. So this is the concept. Okay. So I hope you have understood. Now we come, so we have discussed the reasons behind the extreme cold. So western disturbances, they are going to bring cold weather. Then we have discussed the Siberian cold air mass also, the lack. Okay. Now the important concept we have to discuss is the pollution. We have already discussed the impact of the weather. Lack of western disturbances will adversely affect the rabi crops such as wheat, and the cold might even extend all the way to the south. if a north south trough exists, low pressure. So this cold weather may also affect the south. In south we have crops, important crops like crop coffee, which are susceptible to sensitivities. They are sensitive to changes in temperature, so they will be also affected. Now, how is pollution going to be affected by La Nina? Now what is happening is, right now there has been a delay in La Nina. So during October months, normally what happens is that the monsoon starts retreating, but still there is high humidity, high amount of moisture in the atmosphere, but not a lot of rainfall, very less rainfall, and also calm winds. Okay. So, in case of calm winds, high humidity, what will happen is the particles. The dust particles, they are not dispersed. They are not dispersed. They settle near the surface, and also the temperatures are getting colder. So that is why cities like Delhi, they have already entered the very poor category in the AQI index of the quality of air. Okay. So in case of La Nina, if La Nina somehow it settles or arrives, it settles comfortably by December or January. So what will happen is, it will start, because these are strong winds. So although it will bring in extreme cold weather, but it will also help in dispersing the pollutants. Okay. But don't think that this will cause a reduction in the pollution, because it is a double-edged sword. Why? Because the excess cold, what it will do is, the excess, when the cold is excess, at times, often it happens that the land, the air near the surface of the land, it gets colder, it gets cooler than the air above it. Normally, what happens is, as we go above, as the altitude increases, the temperature decreases. Okay, so here cold air is there. Okay, but above it, what will happen is, we will experience a layer of warm air, warm atmosphere. And again, normal, will then experience the cold air. Normally, the warm air should be nearest to the surface. Then, as we rise in height, the temperature should decrease. But here, if we make the temperature scale, if the temperature is increasing in this way, so what will the temperature graph look like? It is decreasing this way, then it is increasing, then it will decrease. And this layer is known as the inversion layer. Okay, where the temperature rate of increase or decrease of temperature is not following the norm or the tradition. So now what will happen is, this calm air is near the bottom, near the ground, so it will not allow the dust particles, the pollutants, the PM5, PM2.5, and the PM10 particulate matter to rise, because air is calm, it is dense, it is heavy, it will keep it as it is. It will, the pollutants, dust, soot, whatever pollutants, particles are there, they will remain suspended near to the ground, and it will aggravate the problem of pollution. So this is a double-edged sword. Okay. One last interesting condition, because obviously we blame stubble farming a lot when we talk about the culprits behind the increasing pollution in the plains. But it has been established that stubble burning is not a major cause. The major cause is whatever is happening within the city: lack of green spaces, excess pollution, industrialization, haphazard urbanization, vehicular pollution, And also these external factors like Enzo, La Nina, and the El Nino, these also vary. Now, normally the fault of the government, where the government is lacking, we'll discuss that. So in 2022 and 23, when we were encountering the La Nina condition, we observed something very unique. We observed the decrease in pollution in Delhi and other adjoining areas due to stubble burning. So, what happens during the winter season normally? The direction of flow of wind is from is westerly, that is from the northwest side. It is from the northwest side. So this northwestern, because air is going to move from high pressure to low pressure, so here we have relatively higher pressure to this. So here if there is stubble burning, stubble is burning in Punjab and Haryana, so these winds blowing from northwesterly direction, it will carry the pollutants towards the Delhi NCR area. But what happens during what has been observed during the La Nina conditions, that these winds, instead of having this northwest to southeast direction, these have been observed to take this direction due to another phenomena, due to stronger winds from the eastern direction. So these winds which were bringing the pollutants from as a result of the stubble burning from the northwestern direction, these were diverted. So the pollution was diminished. It was not as significant as on normal as in normal winters. It was so these lower areas, these these areas, Mumbai, Maharashtra, Karnataka, these areas, it was observed that pollution becomes high. So it's a double-edged sword. So if La Nina is there, then it might help dispersing pollutants, but La Nina is not there. So northern and southern. So these are some of the aspects. So you can see how the vagaries or the variations in the atmosphere, they cause changes. Okay. So this was all about pollution, how it is affecting, and the bonus content, although it's been a relatively long lecture, but the criteria for determining or declaring a cold wave. We might experience lower than normal temperatures at a particular day, but not every such day can be declared as a day of cold wave. So, IMD, like not every phenomena or instance of heavy rainfall can be termed as a cloudburst, but we normally use that term, but there is a fixed criteria. So, cold wave also, there is a fixed criteria. So, first of all, the initial criteria would be, because there are different areas, plains, hills, the coastal regions. So the minimum criteria for declaration of heat waves is that at plains the temperature should be less than 10 degrees Celsius. Okay. In hills, the temperature should be less than 0 degrees Celsius, below 0 degrees Celsius, apart. So this is the main conditions at particular. So the temperature is recorded at a particular station. So the temperature should be below this threshold. And besides this, it has to fulfill one of the two conditions. So one condition is that departure from the normal, temperature departure from the normal is between 4.5 degrees Celsius to 6.4 degrees Celsius, greater than equal to. So if this condition occurs along with this is for plains. So for example, plains temperature is less than 10 degrees Celsius and the departure from the normal minimum temperature lies in this range, it will be termed as a cold wave. Okay. If the departure of temperature difference or departure is greater than 6.4 degrees Celsius, then it will be termed as a severe cold wave. Fine. So this means? A simple example I will take. So for instance, on a particular day, the in the plains is should temperature in the plains should be 12 degrees Celsius, the normal minimum. Normal minimum temperature should be 12 degrees Celsius, but instead of 12 degrees Celsius, the minimum temperature has been observed to be 7 degrees Celsius. So it is fulfilling this criteria, less than 10 degrees Celsius in a place like Delhi. And moreover, the difference between the departure which we are talking about, it is 5 degrees Celsius. The difference which lies in this range. So it will be a cold wave. If the temperature had been 3 degrees Celsius, so the departure or difference will be greater than 6.4 degrees Celsius. It will be known as a severe cold wave. Fine. So for hills, this criteria is there. For plains, the temperature criteria is the temperature should be less than 15 degrees Celsius. Okay. So this is one condition. And the second condition is that the absolute temperature, if it is less than 2 degrees, if it is less than or equal to 4 degrees Celsius, so it is already fulfilling the first criteria. That 10 degrees Celsius criteria has to be fulfilled. And if this criteria, if either of the two, either departure or absolute minimum temperature has fallen below 4 degrees Celsius, then it will be called a day of cold wave will be declared. And if the absolute, we're talking about absolute temperature, if it falls between less than or equal to 2 degrees Celsius, then it will be called as a severe cold wave. Fine. So this is an extra bonus material. So at the end, I would like to conclude. It's saying like a lot of ministers are saying, okay, put monitoring stations, put anti-smog towers, and these are just temporary or namesake measures. On the long run, we not only have to move beyond the local centric measure, like when we are trying to curb pollution, we are trying to adopt measures to counter or battle pollution, problem of pollution. We just don't have to look at individual cities like Delhi or Patna. Recently, Lahore was declared as the most polluted city in the world. So it is more regional. We have to discuss the phenomena, how the other regions, the adjoining neighboring regions are affecting, how the wind flow is getting affected, how it is the winds are flowing the directions. All these need to be understood on a larger scale. So it is a slightly complicated topic, but I hope you gained a lot of information, some basic concepts you were able to grasp. So, till we meet again next time, Jai Hind.